we are going to look at a few different practice problems. So first, which of the following is a point that is attainable and not efficient? The answer here is D. So remember, attainable is something you can produce. So this is a production possibilities frontier. Remember that everything that is inside of it is something that you can produce, because this blue line represents the maximum. These are things that use all your resources. So it looks like we have a bakery here. So the points on this blue line are going to be points that use all of your ingredients. So if we take a point inside in this triangle here, think about the area inside of this. So these are going to be points that are attainable because they are things we can make. We don't use all the ingredients, or we don't use any more. It doesn't call for any more ingredients than we have. However, if we look at a point inside the triangle, not on the border, like point D, this is not efficient, because we could figure out it would be possible for us to produce more of both goods. So you think about this point here, call it E. E has more cakes and more pies and is still possible to produce because it is still not outside of this production possibilities frontier. Next. Your favorite Japanese restaurant is running a promotion where sushi costs $1 per piece. According to what we have learned in class, how should you behave? Go ahead and read the choices. The answer here is D. You should choose the quantity such that the marginal benefit of the last piece eaten is $1. So we can actually graph marginal benefits and marginal costs here. So our marginal cost is $1. We have to pay $1 for each piece. Remember, marginal is the cost of one more. Now let's think about marginal benefits. So we've talked in class about how most activities have decreasing marginal benefits. And we've specifically mentioned something like eating is something where you get a lot of enjoyment out of the first bite or the first piece of sushi, but subsequent bites, subsequent pieces of sushi don't give you as much enjoyment. So a decreasing marginal benefit would look like this. So now we have our marginal cost here, our marginal benefit here. So we know that for this piece of sushi and this piece and so on, our marginal benefit is greater than our marginal cost, which means keep doing it. I get $3 of enjoyment out of it. I only have to pay $1 and so on. Now, right when I get to this point, what's going on here is that I am getting $1 in enjoyment out of it, but I'm having to pay $1 for the piece of sushi, which means that this right here is the amount that I should consume. Notice that at that point, I have chosen the quantity such that marginal benefit of the last piece eaten is $1, because $1, you remember, is marginal cost. So it's important to note that that is not answer B, because answer B says choose the quantity of sushi that maximizes marginal benefit. Well, the piece of sushi that maximizes marginal benefit is the very first bite. That is when marginal benefit is maximized. We're not trying to maximize marginal benefit. We're trying to maximize our total benefit, which means we keep eating as long as marginal benefit is greater than marginal cost. Next, a mechanic can install motorcycle tires or car tires. For both types, it takes him 1 minute to install one tire. The mechanic works on an assembly line that can produce both cars and motorcycles. What is his opportunity cost for installing all the tires on a car? So go ahead and read the choices. Right? The answer is B. So remember, the opportunity cost is what you give up for something. So when he installs all tires on a car, he has to give up 4 tires on motorcycles. A motorcycle has 2 tires, which means that he is giving up putting all the tires on 2 motorcycles, because 2 motorcycles times 2 tires per motorcycle is equal to 4 tires. And putting all of the tires on a car means you're putting on 4 tires. So if you think about it as this costs you 4 minutes, right? It takes him 4 minutes to put all the tires on a car. Well, it takes 2 minutes to put the tire on a motorcycle. So you're giving up the chance to spend 2 minutes on one motorcycle, 2 minutes on the next motorcycle. So you're giving up installing all the tires in 2 motorcycles. Next, iPads were originally marketed to business travelers. Over time, parents realized that iPads are also a great way to entertain children. Thus, these children and their parents became new customers for the iPad. This could be represented as. All right, the answer here is A, a shift from D1 to D2. So, one of the things we talked about as a shifter or as an increase in demand is new customers. And so now we have a group of new customers, which are children and their parents who buy them these things. So that is a shift to the right in demand. So that means we are shifting from D1 to D2. One way to think of it is even holding the price of iPads constant. There's some very inexpensive iPads here. What we will get is more people buying them. So when we just had business travels buying them, we sold about 5. Once parents started buying them for their kids, we now increased our quantity to about 10. So again, that is an increase in demand because even with price not changing, we're still selling more because people overall just generally like iPads more because now there are parents who like to buy them for their kids. The last question says, suppose ramen noodles are an inferior good for John. If his income increases, the effect on his demand for ramen noodles would be. The answer here is B, a decrease in demand. So if you remember, for an inferior good, when income increases, quantity decreases. When income decreases, quantity increases. You can also think of this as this means that when quantity decreases, that is a shift left or decrease in demand. When quantity increases, that's a shift right or increase in demand. So we can graph this. Think about his demand was here. Call this D1. After he gets the raise, he doesn't want to buy as many ramen noodles, and nothing has changed about the price of ramen noodles. So we're not thinking about movement along the curve. Something about his underlying willingness to pay, how much he likes ramen noodles, has changed. Because now he sees these more enticing options if he can go eat a steak or something, and so he's less interested in buying ramen noodles, even though ramen noodles haven't had a price change. Which means that, again, holding price constant, so I'll hold price constant at some level of P. He wants to, instead of buying this many, he's only going to buy this many. We can extend this line. So we get to D2, which again is a decrease in demand.